Greetings! Let's tackle proofs by contrapositive with a particular example. So recall a direct proof if you're given an if P then Q statement that you're trying to prove. You start with the P and you work your magic until you get to the conclusion Q. Well, with the proof by contrapositive, what we prove that's logically equivalent is not if not Q, then not P. So if we negate the conclusion and are able to show the negation of the if part, then we have, in a sense, we have proven if P then Q by a proof by contrapositive. So let's see this in action with a particular example. So let's let x and y be integers, and we want to prove that if 5 does not divide the product of x times y, then 5 doesn't divide x and 5 doesn't divide y. So to be clear, let's identify our pieces. So P, the statement P would be 5 doesn't divide xy. And the statement Q would be 5 doesn't divide x and 5 does not divide y. So we need to be able to negate these in order to do a proof by contrapositive. So let's write the contrapositive, and that would be not Q, then P. Alright, then not P. Well, what's not Q? Not Q would be the negation of this and sentence. So remember, when we negate an and sentence, we get an or. So we really get not 5 doesn't divide x or not 5 doesn't divide y, which really means, so not 5 doesn't divide x is 5 does divide x, or 5 does divide y. So this is the negation Q of 5 doesn't divide x and 5 doesn't divide y. Either 5 divides x or 5 divides y. Alright, and so what would not P be? Not P would be not 5 doesn't divide xy, or 5 does divide xy. So on this next board, let's rewrite the contrapositive, or that we will attempt to prove. We are going to say if 5 does divide x, or 5 does divide y, that's my not Q, then 5 does divide xy. And there's my not P. If we can show this, then we have shown P implies Q by contrapositive. Alright, so let's start. We're going to say that 5 divides x or 5 divides y. And without loss of generality, we are going to say 5 divides x. What this means is 5a equals x, where a is some integer. That's what it means for 5 to divide x. Well, what this means is xy equals 5ay, because I've just replaced my x with a 5y. I've just replaced my x with 5a, and the question, which is equal to 5 times ay, and what this means is that 5 divides xy, right? Because I can write xy as 5 times an integer. Alright, so what we have shown is not Q implies not P, which is logically equivalent to P implies Q. So we are done with this proof by contrapositive.